Alright, hello my wonderful students. This is foldable number 4, section 4.3, finding the multiplicities of a zero. So I had to change this one a little bit because I didn't like the way the last one had. And if I would have just multiplied this through, it would have been a crazy polynomial that I haven't showed you guys how to solve yet. So I kind of just did it that way just to make it easier for everybody, including myself. Let me adjust this real quick and then, oops, and then zoom in. Alright, for these two, this one you just kind of have to, similar to what we were doing before, we're going to factor it, find the zeros, and then kind of graph, and then show what it actually could look like. If you wanted to use the calculator to do this, you just have to plug this into the calculator, and it kind of shows you the graph, but we're going to show you kind of how to do it as well. So for this one, similar to the couple foldables ago, we're just going to factor it out. We notice that these all have an x in common, actually have an x squared in common. So we're going to pull out an x squared, and then we have x to the fourth divided by x squared, which just give you x squared. Negative 8x cubed divided by x squared just give you negative 8x. And 16x squared divided by x squared just gives you positive 16. And now we can go ahead and do our x factor. Put the 16 on top and the negative 8 on the bottom. So two numbers that multiply to equal 16 but add to equal negative 4. This could be negative 4 and negative 4. That would give us a actually pretty good multiplicity for this one, because that actually ends up being the x squared that comes through, and then the x minus 4 and x minus 4, which we can rewrite as x squared x minus 4 squared. So if you know this here, if we were to set these equal to 0, this would be x is equal to 0, multiplicity 2. And this one would be, if we do x is equal to x minus 4 is equal to 0, we add 4 to both sides. X would be equal to 4 multiplicity 2 as well, because there's two copies of each. Now we go ahead and we plot our zeros on this side. So we have 0 at 0 and a 0 at positive 4. These are multiplicity 2. So we know that it's going to touch and not actually go over. But before we do that, let's do, since I did that in here, let's do end behavior here. And behavior. And end behavior is based off of this here, x to the fourth. So it is a positive even, which means that it's going to be going up and up. So that means it's going to be coming from the top and then leaving from the top. So this one here, since this is a x to the fourth, you can kind of just get a gist of how it is by submitting. But you know what? Since I don't actually know what's going to happen, because it could technically still do this and go up, because it's still up and up. But I don't know if it actually wants to kiss and go up and then go back up here. So the easy way to find that out is just to plug in a variable here for 1. So we're going to take this here, and we're going to plug in 1 and see if it ends up being negative or positive. So let's go and do that. We'll do that here. We have 1 to the fourth power minus 8 times 1 to the third power plus 16 times 1 to the second power. So this is 1 minus 8 plus 16. This is actually going to give us a positive 9. So we know that 1 is going to be way up here. So we can say that this is going to come from up here in this direction and go here, come all the way back and do something crazy like this, and then go back all the way up and then go back again. Like I said, I'm not 100% sure where this is going to hit, but I know at 1 it hits at 9. 1, 2, 3, 4, 5. So it's going to hit way up here. But it's going to hit like way up there. But you know what? Just going to draw this graph just to see. So you kind of understand what's going on. But once again, these are just using the end behaviors, finding the multiplicities, which we did. We had 0 multiplicity 2 and 4 multiplicity 2. And then kind of graphing it using this in order to figure out what it's going to look like. Testing a point here to make sure that if it's going to go down or up according to the thing. If we had more points, we would test in between each one. And I guess we can test on the outside as well, but we'll do that for the next one.